Hi students, welcome to the chemistry sessions. So today we are going to discuss about the CBSE pattern exercise for the hydrogen chapter, right? And I hope everybody has revised the entire chapter because we are going to discuss 10 questions related to that too very important, which are more likely to come in the exam. So let us start with the question number 1. What does it say? Okay, now the question number 1 to 3 will be 1 mark, so just answer accordingly. What is the trade name of hydrogen peroxide used as an antiseptic? Now that's an important question. So we know that hydrogen peroxide is used as an antiseptic, and what is the name for the compound basically? That is perhydrol. That is the compound. You must learn this. This one is important, and it is used as an antiseptic, that too a mild antiseptic. Mild antiseptic. Fine, clear? Let's move on further then. Okay, so the next question say, which isotope of hydrogen? So we have covered up this particular topic as well, that what all are isotopes of hydrogen. Fine. Okay, so we have got 3 isotopes. So one is protium, right? Another one is deuterium, third one is tritium, right? So this is protium, deuterium, tritium, and this protium is actually H, nothing but the hydrogen we call it, fine. And they are asking does not contain, which of them does not contain any neutron? See here, if one is electron, so one must be the proton, then the neutron will be over here 0, right? Over here neutron 1, over here neutron 2, clear? And I know my answer, that is protium, right? So don't just write hydrogen but write protium, it would be appropriate. Which one is radioactive? So you know it's the tritium, right? Clear? Okay. So let's move on further then. Question number 3. Arrange. Now this one is important. Arrange H2, D2 and T2 in the decreasing order of their right. So I need is the arrangement of these 3 isotopes, right, in the boiling point. So as I have told you that higher the mass, bigger the compound is, that means more the mass, more will be the boiling point. We know this, right? So which one will be having the most most mass, more mass? That will be tritium, T2, then D2 and then finally H2. That is my possible order for the boiling point. More mass, see here, more molecular mass, more boiling point, right? So this particular rule is also followed in the case of hydrocarbons. More the mass of the hydrocarbon, more will be the boiling point, because more is the van der Waals forces of attraction. Heat of fusion or enthalpy of fusion. Enthalpy of fusion, what does it mean? Fusion means it's basically the dissociation of the compound, fine. And we know that heat of fusion will be highest in the one having more mass, right? So again, this would be my decreasing order, right? So done, clear with the fact? Now let's move on to question number 4 then. Question 4. Now it's of 2 marks. Name the classes of hydrides. So first of all, what I would like to tell you over here, hydride topic is very important. Question can arise from this, fine. Name the classes of hydride to which these 4 belong, right? So they have given certain compounds. We need to classify, we need to differentiate in between the different type of hydrides. So we have learned 3 types of, one is the ionic, next is covalent, and the next is interstitial, or also known as non-stoichiometric. Yes, remember this? Covalent or molecular, ionic or saline. Clear? Okay, now let us just classify these 4. 1, H2O, see here. So first of all, this is a covalent compound, fine, you know this, and it's a covalent hydride. To be very precise, the 3 types of covalent hydrides are electron deficient, yes, electron precise, that means exact number of electrons, not more, not less, just the perfect, electron rich, right? Now out of the 3, which one is this? It's electron rich, it has got lone pairs. So it's a covalent molecule, a covalent or a molecular hydride with electron rich component, fine. It's a type of electron rich covalent hydride, you can say. B2H6, again it's an hydride, but that too, okay. So the bonds over here are covalent, so you get to know that this is covalent molecule, covalent hydride. And this boron is electron deficient, right? And we get to know that this one is included under the category of electron deficient. If I talk about NaH, see here, so it's not covalent, it's basically ionic compound, Na plus and H negative it is. So it's included in the category of ionic or saline hydride, fine. And also S block elements usually form ionic hydrides. You must remember this, and that is why I have chosen this as my ionic hydride. If I talk about TiH2 now, this one is good one. TiH2, so some of the very specific examples must have been mentioned in your books as well, and I have also told you that this will be included in interstitial or non-stoichiometric hydrides, fine. First of all, just try to recognize that this is belonging to D block element, right? And this gives us an idea that yes, it would be an interstitial. To be very precise, TiH2 is given. So basically it's not TiH2, but it has got a little deficiency of hydrogen hydride, which is approximately, it's 1.5 to 1.8, not exactly 2. Clear? Yeah. So this belongs to DNF. This belongs to what? P block. This belongs to S block. Clear? Okay. So done with this. This was a very good, interesting question it was. Now comes up the next question. Now, it's a very good question. See here. Rohan heard that instructions were given to the laboratory attendant to store a particular chemical. So they are trying to find out some particular chemical. Particular chemical, that is, what were the instructions given to the laboratory attendant? Keep it in the dark room, add some urea into it and keep it away from the dust. This chemical acts as an oxidizing as well as reducing agent in both acidic and alkaline media. Have you got the compound? What is it? See here, it acts as an oxidizing as well as reducing. We have done this in acidic and alkaline media, and this chemical is important for use in the pollution control treatment also. What is it? So it's a very, very familiar kind of a compound we have did. Hydrogen peroxide it is. See here. So as I've told you, we have to keep it in dark, because again what happens is, let's first of all read the question. Name the compound. It's the hydrogen peroxide, we know this. Explain why such precautions are taken. So the precautions, first of all, dark room, because it easily dissociates in the presence of sunlight, right, giving H2O plus O2, and in order to prevent it from dissociation, we keep it in dark, right. Add some urea into it. Why? Again, it prevents the decomposition of it, fine. Urea is actually acting as a stabilizer into it, right. So urea stabilizes it. And if I talk about the dust, if there is dust, the presence of dust can be very explosive. It will dissociate, it will decompose in the presence of dust explosively, right. So that is why we have to keep it away from the dust in a properly closed container. And that is what the question is. I hope that is clear to you. Okay. So that is it. That was question number 5. And an interesting one. Now, write the chemical reactions to show the amphoteric nature of the water. You have to find out the amphoteric nature, that means water is behaving as an acid as well as a base, right? So, see here, water, first of all, if I am trying to show that this particular is behaving as an acid, then we have to react it with a base, right? And that is, I have chosen ammonia in this case. I get is NH4 positive plus H plus. Since this is giving H positive, see here in the equation, that is why it's acidic. If I talk about that it behaves as a base, so I am going to react it with a species so that it leads to the formation of something, right? What is that? So it's basically SH negative plus what is left? Yes, is it? So I hope everybody has got it, that I am left with OH negative over here, thereby making this as a base. Yes, clear about the fact? So that was okay, wait for a moment. Wait for a second. What I've done over here is see this particular reaction carefully. Whenever NH3 is fetching one oxygen, we get OH negative here, see. Right? The correct equation is this. Now, if I talk about here, now that is why I was getting confused over here. You must get H3O positive plus SH negative. Now, it's perfectly correct. And yes, with that matter of fact, it changes. Yeah. So, it shows these two both reactions shows its amphoteric nature. Clear? So, I hope that is clear to you. That is acting as a base, that is acting as an acid, that is acting as a base, that is acting as an acid. Clear? Okay. Now, let us move on further then. Yeah. Question number 7 to 9 now, 3 mark questions. Calculate the volume strength. Now, this one is important. And yes, so we are going to solve it together here only. Calculate the volume strength of 3% solution of H2O2. Now, I need to find out the volume strength. That means volume taken for 3% solution of H2O2, right? Volume strength means I need to calculate the volume per, strength means per liter of the solution actually, right? Volume specifically I am talking about for what? Let us see here. So, basically 3% solution of H2O2 means 3 grams, right, will be dissolved in 100 ml of solution. And now we are talking about the 1000 ml. So, 30 grams will be dissolved in 1000 ml per liter I have calculated. Fine. Now, if I talk about the reaction, see here, the reaction basically is the formation of oxygen, right? Fine. Balancing it out, right? So, here what is the molar mass of H2O2? We know this, it is 34 into 2 will be giving how much of oxygen? See, it is 1 liter, 1 mole, fine, and that too 1 mole will be corresponding to, if I talk about at NTP, right, it is 22.4 liters, fine. So, basically 68 grams will be corresponding to 22.4 liters, fine. See here, so 30 grams will be corresponding to how much, right? Let us find out. 30 grams will be corresponding to 22.4 liters by 68 into 30. Now, what do we get over here is, we get 9.88 liters, fine, approximate value, and that is per liter of the solution. Now, if I talk about in ml, right, so that was when 1 liter was giving, that means 1000 ml of solution was giving 9.88 liters, fine. So, that means if I talk about 1 ml will be giving 9880, this will be in ml, fine, divided by 1000. and that comes out to be 9.88 ml, and that is the answer, that is the volume strength for what? What have we found out? We have found out the volume strength for this particular solution in the terms of oxygen, the value of oxygen. Clear? I hope that is clear to you. Done? Let's move on further. So that was question number 7, and let's take up the question number 8 now. Molecular hydrates, again the hydrate question has come up, are classified into electron deficient, electron precise, electron rich compounds. Now explain each type with 2 examples. So you know this, we have just done this. Electron deficient means they have got incomplete octet. In that I have got is B2H6, Al2Cl6, right, and a lot many. Fine. So the octets of them are not complete. I am not going to discuss the entire thing, but just an idea of it. Electron deficient, electron precise. Electron precise means exactly complete thing. Fine. And one more, what you can name? C2H6, right? Yes, done. Next one, electron rich. Electron rich can be, we have just done this, H2O, one more NH3, one more HF. Yes, all of those have got extra pair of electrons to donate. Clear? Okay. So that was it. Yes, we have to properly define it because it's a 3-mark question. You have to properly define each and every part of it along with the examples. Next, what does the question say? How is H2O2 manufactured by the electrolysis of water? Give its structure. So basically, what one electrolysis method for H2O2 we have discussed, and that is not just water, but you know, the solution of acidified sulfate, right, that is H2SO4. So basically 50% of solution, write this down, this is very important, 50% of solution of H2SO4, right, and again the solution is made up in H2, right. So here is the electrolysis method for it. Electrolysis, it's high density current, so it's high electricity we have passed through it, high electric current, and after that what do we get? We get over here is peroxodisulfuric acid, right. So it's OSO3H, OSO3H. What is this? H2S2O8, peroxodisulfuric acid. Yes, and finally what do we do is hydrolysis, right? We do is hydrolysis of it, and we again get back HSO4 negative plus H positive plus my production of H2O2, right? Clear about it? Okay. So basically it's not water, electrolysis of water, but to be very specific, it is the H2SO4 or sulfuric acid solution, or you can say the acidified sulfate solution. Clear? Now the remaining part, give it structure. They are asking about the structure for hydrogen peroxide. Can you do that? So it's very, very easy. So we have got 2 kinds of structures for it. One is in the gaseous phase and one is in the solid phase. So that is how the structures are. First of all, you have to make a non-planar thing over here, right? And yes, now try to place the molecule. H, H, O, O, H, H. Now just tell me the dihedral angle in both of them, and to be very specific, this is the gaseous phase and that is the solid phase. So basically in gaseous, the dihedral angle is more, 111.5 degrees, whereas if I talk about here in the solid phase, it's slightly less, 90.2, that's it, right? Other specifications you have to write it on your own. Over here it would be 95, it would be 98, that is the length I am talking about this, right? And this one will be 147, 145, clear? Okay. So let's move on to the next particular compound. The question. Yeah, the remaining question, in fact, the 10th question, and that too a 5-mark question. Now it's very interesting. Explain the following. So the first part says a solution of H2O2 cannot be stored in for a longer period, because we know that in the presence of sunlight it starts decomposing. So it slowly decomposes, right? So that is why I cannot store it for a longer period of time. That is why we add stabilizers like urea in it. Now, anhydrous BaO2 cannot be used to prepare H2O2 by reacting with an acid. So see, actually what we have done is, what kind of a reaction we have done? Not anhydrous BaO2. Remember, we have taken up barium peroxide, yes? But we took it, we have did the preparation for H2O2 by BaO2, but not anhydrous. We have got is, in the case is, it's hydrate 8H2O in the presence of H2SO4, right? And that is how the reaction will be taking place. So why we have taken this? In order to have a proper solution of it, so that we can get BaSO4 plus H2O2 formed, right, along with H2O, so that what happens is, in this reaction the extra H2O is removed by evaporating, so that more and more compound is formed, and that is why we cannot take up, it is actually unreactive in the presence of anhydrous. Clear? Okay. Next one. Liquid hydrogen cannot be used easily as a fuel. Why is that so? So first of all, the storage problem. Yes? Why the storage problem? Because again it's a heavy container, right? We have discussed about this, that it's approximately how many times? 30 times heavier than what we have got in the form of petrol, right? The same amount of energy if we calculate. First is the storage problem, another is liquid hydrogen, see here. That means liquefying, again what do I have to do? We have to lower down its temperature, and that to approximately 20 kelvins, which is very difficult to attain, right? And yes, again there is a leakage problem in that. So many problems, and that is why it cannot be stored easily as a fuel. Done? Okay. Now the last one, discuss the principle and method of softening of hard water by synthetic ion exchange resins. Now that is an interesting question. We have done the synthetic ion exchange resin, yes. What is the principle first of all? First of all, the principle is nothing but the ion exchange only. The ions have been exchanged Na, see here. So it's a synthetic ion exchange resin. Synthetic resins have a long carbon chains, hydrocarbon chains, along with SO3H group. First we convert it into, by reacting it, NaCl, RNA, right? See here how the exchange is taking place. I have got my metal ion to be removed. It can be Ca2 plus Mg plus 2, right? And it gets removed something like this, plus Na positive. Fine? And yes, that is the basic principle of ion exchange. Yes, you can very well see over here, it's ion exchange, right? Now the next thing, I have got two things for you. Describe the principle and method of softening. So method is cationic, the introduction of cationic exchange resin and anionic exchange resin. Right? And you know what is the purpose of both of them? First one is which gives up H positive, the other one is gives up OH negative. So basically softening of hard water, that means giving us this particular, these two resins, they give us pure demineralized water, that means no ions found in it, right? How is it going to work? See, RH plus M plus 2 will be giving what? It will be giving R2M along with H positive. Now the water has become this ion free, right? M ions have been removed, can be removed as a precipitate. But what do we get is, we get the water turning acidic. Now in order to maintain this acidity, what happens? Let us assume that this M was Mg, right, and its counter ion will be Cl2. Now there are Cl negative ions also, we have to remove that also. What happens? I have got anionic exchange resin. First, it reacts with OH negative, giving R NH3 positive. Sorry, it reacts with H2O first of all, right, in the solution form. Now this one, this entity which you see over here, this is anion exchange resin which reacts with X negative, that is the Cl negative, which will be possibly in the solution form, giving us a salt, right? Plus, now here also the principle is same, exchange is taking place. Here also the principle is same, exchange is taking place, fine. And what do we get over here? We get is OH negative ions. Now this H positive and OH negative can combine in the solution, making it neutral, and finally the demineralized, deionized, perfectly pure water, in fact distilled water we call it as. Clear? And yes, you need to know that how you have to frame the entire answer. That means they are asking about the principle, so justify your answer properly so that you get proper marks. Clear? Okay, now this completes my entire questionnaire of 10 questions. I hope everybody has understood this very well. If not, just you can reach out to me anytime. I will be available for you to take the queries. And yes, you have to go through it once again so that you do not forget any one of the questions, because we have picked up the important ones from the chapter. Have a nice day.